Welcome to a short introduction to resistor color codes and how resistors are labelled. First question. What value is this resistor? If you think it's a 102 ohm resistor, I'm afraid you're wrong. Surface mount resistors like this, with 3 digits on them, cannot just give you their value because there is only room to print 3 digits on the resistor. So what do you do if, for example, the resistance was 470,000? Instead, they use a technique where the first 2 digits, in this case the 1 and the 0, are the 2 significant digits in the value, and the third digit is known as the multiplier. It's the number of zeros that you add on the end. So this is actually saying it's 1 0 and then another 2 zeros, which is 1000 or 1000. This is a 1000 ohm or 1K resistor. There's lots of other examples we can do as well. A 103 resistor would be 1 0 followed by 3 zeros, or a 10K resistor. A 100 resistor is 1 0 followed by no more zeros, so that's just a 10 ohm resistor. What, you might be wondering, do you do about a 4.7 ohm resistor? And the answer is that would be labelled like this, with the standard engineer's technique of replacing the decimal point with the SI multiplier. In this case, we just replace it with an R. That means 4.7 ohms. The same idea of having 2 significant digits, or sometimes 3 significant digits, followed by this multiplier, which tells you how many zeros to add to the end, is used for the color code scheme of labelling resistors as well. You've probably seen resistors like this before. They're labelled with colours. They are easier to paint on resistors than actual letters. It is important, though, to be aware that when you have a 4-band resistor like this, the 4th band isn't part of the value of the resistor. It tells you the tolerance of the resistor. So we have 4-band resistors like this. 2 of the bands give you the significant digits, like the 1 0. The 3rd band gives you the multiplier, the number of zeros that you have to add. And the 4th band gives you the tolerance, how accurate the value of that resistor is guaranteed to be. After a while, you'll get to know what numbers these different colours correspond to. The way I remember this is black is nothingness, 0, absence of all light. Brown is quite close to black, so that's 1. And then you go through the colours of the rainbow, the 6 colours of the rainbow. Despite what many of the songs and stories tells you, I don't think there are 7 colours in a rainbow. Have you ever looked at a rainbow? What is the difference between violet and indigo? How could you tell the difference between a violet stripe and an indigo stripe? No, we just use 6 colours here. Red, orange, yellow, green, blue, violet. The 6 colours of the rainbow. Counting up 2, 3, 4, 5, 6 and 7. 9 is white, because 9 is the biggest number, and white as a colour contains all of the other colours. It's everything, so it's the biggest one, 9. Grey is almost white, so it's 8, closest to 9. Not a brilliant way of remembering it, perhaps, but it works well enough for me. So, consider this resistor here. It's got 2 brown stripes, a blue stripe, and then a thicker red stripe separated by a slight gap. Now that's important. One of the problems of identifying resistors is to know which way round to start reading them. Sometimes it's not obvious whether you should start reading from this end or start reading from that end because you don't know which way round the resistor is. It's helpful to be able to spot things like a slightly larger gap between the multiplier band and the tolerance band, or the tolerance band being slightly thicker than the other bands. Something different about that band, which identifies it as the tolerance band. Anyway, back to this resistor. What we've got here is brown, brown, blue as the value. Brown is 1. The next brown is 1. Blue is 6, which means we have to add 6 zeros. That gives us a 11 mega ohm, an 11 million ohm resistor. The tolerance band is red, and red as a tolerance is 2%. Just like red as a colour is 2. If that was a brown tolerance band, it would be a 1% tolerance resistor. Some of the other tolerance colours are a little bit harder to remember. Green doesn't mean 5% tolerance, it means 0.5% tolerance. Blue is then 0.25% tolerance, and violet is a 0.1% tolerance resistor, if you ever see them, but they're quite rare. There's a quiz app topic on colour codes, and it will supply you with an almost infinite number of problems to work through. For example, what resistance does this resistor have? Well, brown is 1, orange is 3. Orange as a multiplier means add 3 zeros. That is a 13K resistor. How about this one? Red is 2, violet is 7, blue is 6, so we add 6 zeros. That is a 27 megohm resistor. The only slight problem with this technique is what happens if you want to label a 4.7 ohm resistor. You would label that as yellow for 4, and then violet for 7, and then you don't want to add any zeros on the end. In effect, you want to take a zero away. You want to multiply this by 10 to the power of -1. Because you can think of these multiplier bands here, not in terms of the number of zeros that you want to add, but in terms of multiplying by 10 to the power of the number represented by the colour. So this resistor here you could think of as 2, 7 times 10 to the power of 6. To label a 4.7 resistor, what I'd want to do is label it as 4, 7 times 10 to the power of -1. I need a colour which represents the number -1. And there is one. We use gold. If I wanted to label a 4.7 ohm resistor, I would label it as yellow, purple, gold. And gold represents -1. Final example I'll show you. Oh, yeah. Sometimes if we wanted a 0.47 resistor, then we'd have to take 47 times 10 to the power of -2. We need a colour that represents -2, and for that we use silver. Anyway, final thing to mention, some of the resistors don't just have 4 bands, they have 5 bands, like this. If they have 5 bands, then they have 3 significant figures. So this one would be 3 for orange, and then 6 for blue, and then 0 for black, and then times 10 to the power of 1 for brown. So that would be 3, 6, 0, add 1, 0. That would be a 3600 ohm resistor, which I would usually write 3K6. With a bit of practice, this will become second nature. And it's really important because most of the resistors that we'll be using in the degree do have these coloured bands, and you need to be able to identify the resistors just by looking at them and reading their values. If in doubt, and sometimes it can be difficult to know which direction to read the resistors in, just measure them on a multimeter. Okay, you should now be ready to have a go at the quiz app topic on colour codes. Good luck.